Okay, hi guys. So in this video, we're going to talk about translations of tangent and cotangent. And so just as a reminder, so with tangent and cotangent, so we have period, phase shift, and vertical shift. We don't have to worry about amplitude. And determining these things when you have translation works very similar to if you're familiar with sine and cosine. So I thought it would be good to just first get used to finding period, phase shift, and vertical shift for each of these functions. So let's just review how do I do that. So let's start with just like a basic function like 3 tangent 4x. So to find the period, so period is always found by taking pi over b, and b is whatever number is attached here. Now this can get trickier if you have a bunch of translations, and I'll show you how to work with that in a few minutes. But for now, this number in front here, so if I take pi over that, that's going to give me my period. And then we have the phase shift. So phase shift in this case, we have none. So that would be something being added or subtracted to the x. So we'll see some examples of that as we go along. And then there's also no vertical shift. So this is what your like standard tangent function, right? Okay, so now let's start taking a look at what happens when we have different types of shifts. Okay, so one thing I just want to note, since there's a minus sign in front, so this means that this function is going to flip over the x-axis. That's not necessarily a shift, but I do want to note that. Okay, so for the period, so once again, so it's whatever number is in front of the x. In this case, there is no number in front of the x, right? So we can assume it's a 1. So my period is going to be pi over 1, which just equals pi. And then for my phase shift, so again, that's whatever is being added or subtracted to the x, as we see here. So my phase shift will actually be negative pi, or we could say pi to the left, tomato, tomato. And then there's no number outside of this function, so at the moment we still have no vertical shift. Okay, so let's keep going with this. So now what if I have 2 tangent 3x minus pi over 2? Okay, so this is where phase shift can get a little tricky. So usually what we like to do when we have like a number here and a number here is we want to factor the number attached to the x out like this. So it's going to help to factor out the 3. So if I factor out the 3, when I factor this out, I'm going to multiply the denominator of this fraction by 3, which is equivalent to dividing this fraction by 3. So this is going to be a standard trick just like we use with sine and cosine, so we want to use that here. So once again, so now when I go through everything, so my period in this case is, now it's that number that I've factored out, so pi over 3. And then this factored form makes this determining what the phase shift is very simple. So it's just going to be pi over 6 to the right. So it always works in opposites, right? And then there's still no vertical translation, so that would be a number just outside of the function, which we don't see. Okay, so I think that you know enough about this that I think you can probably just give this one a try. So remember, math is not a spectator sport. You know I say that all the time. Give it a try. Let's just check your understanding. Hit play when you're ready. Okay, so in this case, my period is going to be pi over 1, which is equal to pi. And then, so I have no number here, so that really makes this a lot easier. So my phase shift is going to be this 4 to the right. And then I do have a vertical shift, so that's this number on the outside, so that's going to be 3 moving 3 up. Okay, so let's keep going a little harder with this. So now let's move on to E. So now here's a case where you are going to have to factor this, and I want you to try this on your own to make sure that you've got it, and then hit play when you're ready. Okay, so if I factor this, so notice I'm going to factor out 2 pi, and I want to make it really clear what I'm doing. So I factor out 2 pi. So I'm going to multiply the denominator of this fraction. I'm going to multiply it by 2 pi and see what I get. So this simplifies to what you see here, 2 pi times x minus pi, or 1 over 8, sorry. Okay, so once I have this form, it makes everything else simpler. So if you haven't yet, I would suggest pausing and trying to find the period and the phase shift and the vertical shift. Okay, so in this case now, my period is going to be pi over 2 pi. So I just take this number, right, and then put it under pi. And that will simplify to 1 over 2. My phase shift is just this number here. So it's minus 1/8. So that would be 1/8 to the right. And then I have a vertical shift. So this is negative 2. That's a number on the outside, so it's 2 down. Okay, so just to make sure you're really comfortable with this, I have one more of these. Pause the video here, give it a try. Let's make sure that you're good, and then we'll keep going. Okay, so once again, I want to rewrite this function as you see here. So in this case, so I'm just going to divide this 2 by 5, and then that will help me factor this out. And so then I've got my period is pi over 5. My phase shift is 2 2 over 5 to the left, and my vertical shift, this is a positive number, so this is 1/2 up. The one thing I don't have noted on here, but I do just want to note it to us, so the graph does flip here. Okay, cool. The other thing that's going to make or break you when you graph is you've got to know how to find the asymptotes, because that's actually going to help you decide what points to put in for your table. So if I start here with this first example, just how do I find the adjacent asymptotes? So I talked about this in my video on my previous video on tangent and cotangent. So if you have tangent, you have a function y equals tangent of bx. You solve whatever's in the bx place. You solve this two-part equation. Bx equals negative pi over 2 and bx equals pi over 2. And then if you have cotangent, you set that up as bx equals 0 and bx equals pi. So this is kind of like your little guideline, Bible, whatever you want to call it, for how to find your asymptotes. So in this example, I look at 4x. So I set this up, and this is tangent. So I set up 4x equals negative pi over 2 and 4x equals pi over 2, and then I just go through and I solve for this. So remember, dividing by 4 is equivalent to multiplying by 1 over 4. So this is negative pi over 8 and pi over 8 for those. Okay, so let's do this just a few more times. Again, like I said, this really makes or breaks you. That's why I spend time doing this. And oh, just one other thing. So whatever the lowest one of these is, this is where you want to start in your table. So I think we'll add that on too. So I want you to also just note, where would I start the table as we go through these exercises? Because once you've got this, you are going to be great with this. Okay, so let's look at example B here. So now I want to know what are my asymptotes. So I've got tangent here. So once again, I'm just going to take whatever's inside of the parentheses for tangent, and then I just set all of that equal to the two-part equation. So I've got 3x minus pi over 2 is negative pi over 2, and 3x minus pi over 2 is pi over 2. Okay, so now I can go through and solve. So first I'll add pi over 2 to both sides. So that's going to give me 3x equals 0 and 3x equals pi. And then I can divide both sides by 3 to get x equals 0 and x equals pi over 3. And then just we want to note here, this is where I would start my table. So we're just kind of keeping note of that, because once I start graphing, you're going to totally know what to do. Okay, 2 more examples, and then I think we've got it. So I've got this example, we already saw this before. Once again, this is tangent, so I just take the inside part. So I've got 2 pi x minus pi over 4 equals negative pi over 2, and 2 pi x minus pi over 4 equals pi over 2. Okay, so now I can go ahead and add pi over 4 to each side. So if I add pi over 4 to each side, I get 2 pi x equals negative pi over 4, and 2 pi x equals 3 pi over 4. Divide both sides by 2 pi. So remember, dividing by 2 pi is the same as multiplying by 1 over 2 pi, and so that will simplify to negative 1/8 and 3 over 8. And then I just want to start my table here, so I'm just going to note that. So if you haven't tried one of these yet on your own, notice that this is cotangent. So with cotangent, you do have to use bx equals 0, bx equals pi, so just a reminder of that. So I highly recommend that you try this one on your own. Hit play when you think you've got it. So I've got 5x plus 2 equals 0 and 5x plus 2 equals pi. So I go ahead and I solve those, subtract 2 from both sides. So I get x equals negative 2 over 5, or x equals x minus 2 over 5. If you broke this up into 2 different fractions, that's totally fine. You didn't have to though. And then this is where I would start my table. Okay, so I think we kind of have the starting parts of this set. So now I want to look at a few examples. So we're going to graph cotangent of x plus pi over 4. Of course, I first want to determine my period and my asymptotes. So my period in this case, I just have x, so that means that my period is going to be just pi. So when I'm setting up my table, pi divided by 4, I want to take pi divided by 4 steps. And then this is cotangent, so I need to set up my 2 equations for the asymptotes. So I take out this inside part. I've got x plus pi over 4 equals 0 and x plus pi over 4 equals pi. So easy enough to solve. I get x equals negative pi over 4 and x equals 3 pi over 4. Just noting, this is where I want my table to start. And when I reach the end of my period, this should be the end when I'm using my steps, if I'm doing this right? So I start at negative pi over 4, and now I'm going to make those pi over 4 steps. And I can just do this in my head. So I'm just going to add pi over 4 to this. So negative pi over 4 plus pi over 4 is just 0. Add pi over 4 again, I get pi over 4. Add another pi over 4, I get pi over 2. 3 pi over 4, pi. Sometimes I like to do just this last one just to make sure that I like it's a little check for myself. But notice we hit that end of the period, right? That was the end that we were supposed to get to. So bada bing, bada boom. All right, so now once you get that, it's just a matter of finding your y's. So let's make some space and let's do that. So now I'm just going to start plugging these in. So if I plug in negative pi over 4, so look at what I get. I get cotangent of 0. Cotangent of 0 is undefined. So you might want to use the tables that we set up for tangent and cotangent to help you figure some of these out if you're not totally comfortable with these yet. That's actually that's got a good little cheat sheet in there for you. So cotangent of 0 is undefined. Then I plug in 0. And so cotangent of, this will just be cotangent of pi over 4, and that equals 1. So I talked about that all in the last video, so I'm just kind of grazing over that now. If I have cotangent of pi over 4, so cotangent of pi over 4 plus pi over 4 is going to give me cotangent of pi over 2. Cotangent of pi over 2 is equal to 0. And then if I do pi over 2, if I plug that in, that'll come out to cotangent of 3 pi over 4, so that'll equal negative 1. And then at 3 pi over 4, this will be undefined. And then you can check my math here, but then the interval will start over again. So, okay, we have our points. Ta-da! Okay, so now I have to come up with my axes. So my axes, I'm going to go from 1 to negative 1, and then I will go in intervals of pi over 4, pi over 2, 3 pi over 4 pi. However you want to set this up is up to you. Now, with tangent and cotangent, the first thing that you want to do is you want to set up those intercepts. So where you have these undefines, that's the first thing that you want to graph. That kind of gets you started. And then I need to plot these 3 points to start. So I'll go ahead and plot those. So boop, boop, boop. Okay, so now I can connect them. And so now I've got one period of cotangent. Now that I've got that pattern set, I can continue the pattern through the graph. So I can set up more points like you see here. And then I can just continue to expand this to make my cotangent. And so there you have it. So this should feel somewhat familiar. Very similar to how we worked with sine and cosine. We're just adjusting it a little bit for tangent and cotangent. So I want to do one more example, and I do have another video with more examples if you'd like to see more. But anyways, so I chose something that looks a little funkier, if you will. So negative 1 plus 2 tangent 4x plus pi. Say that 10 times fast. All right, so let's start by finding the period and the asymptotes. I highly recommend that you do this to make sure that you've got this. So I would actually say that you should pause here, find your period, find your asymptotes, set up your table, do the whole thing, and then hit play when you think you've got it. Remember, math is not a spectator sport. Okay, so I'm going to start by finding my period. So my period is going to be pi over 4. And so just what that means is if I take pi over 4, so that's going to be, remember when you divide by 4, that's the same as multiplying by 1 over 4, so this is going to be pi over 16 steps. So these are the steps that I want to take in my table. Then for my asymptotes, I set this inside part equal to, so this is tangent, so I'm going to set it equal to negative pi over 2 and pi over 2. So then I go through and I do the work. So I subtract this pi, so I'm left with 4x equals negative 3 pi over 2 and 4x equals negative pi over 2. And then when I finish this, this becomes negative 3 pi over 8 and negative pi over 8. So this will be a little challenging in setting up the table. However, this is a very good challenge. So it's just fractions. It's just a little bit of fractions, just a little addition. Don't be afraid. If you haven't tried to set up the table yet, set up the table, see if you get it right. If you can get it right with something like this, then you'll be good in all of the other cases that have easier math. Okay, so I am going to remember this is the start, this is the lowest, and then this is like this negative number should be where my end is. This will end up being the highest value in that interval. Okay, so I start at 3 pi over 8. Remember, I want to take pi over 16 steps. So something that might be helpful to remember, just negative 3 pi over 8. So that's equivalent to negative 6 pi over 6. Now remember, when you add this, you're adding something positive. So I will go from negative 3 pi over 8 to negative 5 pi over 16, right? So when I add pi over 16 to negative pi over 16, that becomes negative 5 pi over 16. Don't let the negative throw you off. I think that's a really easy mistake to make. Okay, so I'm going to keep adding pi over 16. So then this becomes negative pi over 4 because I get negative 4 pi over 16, which will simplify to negative pi over 4. And then I get negative 3 pi over 16, and then I get negative pi over 8, which, hey, that was the end of the period that we wanted, right? So we have done it right, hooray. Okay, and so now we can go through and we can find our y's. Okay, we're in the home stretch here. So now I can start plugging these values in. So first I'll plug in negative 3 pi over 8. So I plug it into my function. And so I can go through and I can just simplify everything like you see here. So ultimately what I get is negative 1 plus 2 times tangent of negative pi over 2. And then I know that that will be undefined because tangent of negative pi over 2 is undefined. And remember, this was supposed to be an asymptote anyways, so this is good that this is undefined. So we're all good here. Okay, so continuing on, I'm going to plug in this negative 5 pi over 16 into my function. So once again, I can go through and just kind of work out the calculation here. And so this will ultimately give me negative 1 plus 2 times tangent of negative pi over 4. And so then that'll come out to negative 3 if I work it all out. And I've got all my work here in case you want to pause the video and review that. Then I can plug in negative pi over 4. And again, I'm just kind of showing you the work here. So if you haven't tried this on your own or you made a mistake, you can review my work just to see how I got these values. But just for the sake of time in this video, I'm kind of going through it a little quickly here. So now plugging in negative 3 pi over 16. So again, I'll show you all the work for that. So this one will come out to 1. And then at negative pi over 8, we know that that's undefined. So you can check my math on that. And okay, so now we've got all of our points. Now, the one thing with this particular example is these are all negatives. So this graph that I've been using over and over in all these videos, it's not really going to work. I'm going to shift my graph over and I'm going to create a different graph. And then I can go ahead and label it with whatever axes that I want. So you can see how I've chosen to set this up. And so from here, you know that we're going to first make our asymptotes. Boom, boom. And then I'll plot these 3 key points. So bink, bink, bink. And then I can connect them. And then I can just continue the pattern right to bink, 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 bink. I can continue the pattern to make my graph of tangent. So we're all good here. Okay, and so that covers how to do translations. So if that was helpful, consider leaving me a like, comment, sharing this with a friend, or subscribing. And otherwise, guys, I do have some more examples too if you want to check those out. So I'll drop some links in the description. And thanks for watching.